My guest today is Ben Burress with the Chabot Space and Science Center. Today we talk everything about space. We talk about the Space and Science Center. We talk about telescopes and observatories. We talk about the moons Titan and Europa. We talk about so much stuff, including Star Wars versus Star Trek. So hope you enjoy. Very educational and informational podcast. Let's get started. So my guest today, Ben Burress, and I want to thank you for coming onto the podcast. I'm really excited for this because I've always been somewhat of a space nerd growing up.
Excellent.
And we're going to talk a lot about space today.
That's good with me. Thank you for having me. Yes.
So let's just let the audience know, what's your current role right now at Chabot?
So at Chabot Space and Science Center, I'm a content developer and staff astronomer. So what that means is I develop and research content for planetarium shows, exhibits, public programs. I develop planetarium shows. So kind of a researcher of all hats there. We're an educational and public institution, so we don't do science research. But, I have my hands in the exhibits and the shows and anything we might put up on the screen. And my staff astronomer side is anytime somebody in the media wants to talk to an astronomer, I put on that hat. My background is astronomy, so I'm one of two or three there who kind of serve that role too, being the astronomer voices at Chabot.
Nice. So we're here doing the podcast today, and we are enjoying Drake's.
Yes.
Yeah. Now, I assume you're a fan of Drake's, being that you requested Drake's.
Thank you very much. Yes. Yeah. It's not very far from my house, actually, Drake's Brewery. So.
And we're drinking a Jolly Rodger Imperial Red Ale for the listeners, and we will link it up. That's something that we always like to do, beer tasting or wine tasting on the show. So what got you into astronomy? At what age were you where you decided, space?
I probably couldn't say how young I was because as far back as I can remember, I was interested in space. So, I grew up in the 60s. So I remember the Apollo landings and all that, and there's a lot of that going on, all the Apollo moonshots. I barely remember the things like the Gemini, but certainly when they got to Apollo and started sending people to the moon, and of course the landings stand out in my memory very strongly. That and the fact that I grew up in Oakland, not very far from the previous Chabot Observatory. So I work at Chabot Space and Science Center now, but 3 miles down the hill is the previous location of our 2 telescopes, a smaller planetarium, and a public classroom. So my family, we would all go to Chabot Observatory on Friday nights. We'd see the science demonstration or class put on by Mr. Whiteman, who was the director at the time, and go see a little planetarium show on their little 30-foot dome. Wonderful. And then after that, go across the way and up to the telescopes. Go back and forth between the 2 telescopes and see what they were looking at. That was all very impressive to me. I'm sure those 2 things put together, the moonshots and Chabot Observatory being in my backyard, was a really heavy influence on what got me interested. But I was interested in science in general, but I think astronomy particularly sparked me.
Yeah, I feel like that's something that people need to do more these days, is just go to the different observatories and science and space centers and just go check out the different exhibits,
Yes.
telescopes, and just see. I mean, I think it blows my mind away, just our planet and how small we are compared to everything else out there. It's just mind-boggling.
It's beyond mind-boggling.
Yeah.
The size of everything and where we are in it. Yeah.
Now, you went to Sonoma State,
Yes.
correct?
Mm-hmm.
And then you spent a couple years in the Peace Corps
I did.
in Cameroon, right?
I did, yes.
How was that?
It was wonderful. I had a really good experience. When I was in orientation, or rather when they were trying to get people interested at my college to go into the Peace Corps, they made a point of having us talk to a Peace Corps volunteer who had come back who had a really good experience and one who didn't, so that we heard both sides. This could happen or this could happen. It just depends on where you end up, how you deal with the situation, and other factors. And I ended up having a really good experience. I was in a math science teaching program, so it wasn't the kind of stereotypical Peace Corps job, go out and build a bridge in the middle of nowhere,
Yeah.
like John Candy and volunteers. There was already a school, a curriculum, students, so I just had to show up and learn how to teach. So Other than that, it was an amazing cultural experience, obviously, to travel to another country, but into such a different environment. Many things were unfamiliar to me, but I was game to learn them. So I think any situation you go into, if you have that kind of an attitude, I'm going to learn what's going on here and see how I can deal with it, you can do well. But I had a wonderful experience.
Now, you've also done flights above the troposphere, correct?
Yes, in my first real job, they say Peace Corps is first job you'll ever love. I kind of thought of it as the first unpaid working vacation you'll ever love, but it was a job too. But my first getting paid for a job was at NASA, down at NASA Ames, flying on the Kuiper Airborne Observatory. So they had taken a C-141 Starlifter cargo airplane and built a telescope into it, and they'd been flying it since 1976. I started there in '89, so quite a while after they had started. We would fly at 41,000 feet typically, so higher than your typical
commercial
liner, which is about 35,000 feet or so. And the reason we would fly is the Kuiper was an infrared observatory. So it had a telescope, kind of like you would expect in a regular observatory, but their detectors and instruments were all built to detect infrared radiation, so heat radiation. Earth's atmosphere, particularly the water vapor in it, blocks infrared or most wavelengths of infrared radiation. So from the ground, you can't see those infrared emissions from objects in the universe. So if you put it on a plane and you fly up above all the water vapor, then essentially you're kind of out in space at that point. From the perspective of water vapor getting above it, we were pretty much out of the atmosphere.
That's amazing.
Yeah.
So that's one thing that also amazes me is to see things clearly in outer space. Mm-hmm. You literally have to be in outer space because many of the telescopes here, you have to calculate for the distortions that our atmosphere creates.
Right. Yeah, obviously, looking at the universe through our atmosphere is kind of like looking through a ripply piece of glass, a bad piece of glass that makes everything kind of distorted. And if you can get outside of the glass, obviously, you're going to have a clear view. So over the decades since astrophotography started, or just observations through a telescope, they've done their best, but we're limited by the atmospheric distortions in the seeing. More recently, ground-based observatories have been using adaptive optics. So they actually have computer-controlled mirrors that can be commanded to deform in just such a way as to cancel out the
like the distortions,
the turbulence in the atmosphere. So they have a sensor that kind of senses what the atmosphere is doing in terms of rippling or whatever, and it commands the mirror to kind of compensate for that. And they can actually get a reasonably clear image. Some of the images I've seen through adaptive optics have been, as clear and undistorted as like a Hubble image. I mean, not the same kind of a thing, but it takes out the atmospheric distortions pretty well. So that's pretty interesting.
Yeah. Yeah, and even the Hubble Telescope, and I've seen a few documentaries on that Hubble Telescope, and I guess when they first put it out there, it wasn't working properly, and they had to spend a lot of money. They were thinking at some point of just scrapping it, or they had to figure out a way to fix it. And I believe it was the lens that was...
Yeah, the mirror was slightly the wrong shape. To get a perfectly focused image, the mirror has to be shaped into a parabolic or concave shape that is exact to the system that mirror is in for the telescope. It was slightly off. So in effect, everything we were looking at was slightly fuzzy. It was like, a little bit nearsighted. And the fix was to put a corrector lens, kind of like a spectacle, a monocle of a sort, into the optics of the Hubble.
And once they did that, the images just came back incredible.
Right. They had to send a shuttle mission back to fix it, but you're right. It was back to the way they wanted it.
Yeah.
And since then, of course, if you've seen the Hubble images, they are just amazing. I would say that as a single observatory, the Hubble's probably told us more about the universe than any other single observatory.
Now, I heard somewhere they have plans to upgrade Hubble or launch a completely new satellite.
Yeah, they're replacing it.
Okay.
So the James Webb Space Telescope is scheduled for launch this year, I believe. It got delayed a few times, but I think latest I heard it was going to be in 2018. And it'll be a much larger mirror surface. It will be primarily an infrared instrument. So Hubble is primarily a visible light telescope, but the James Webb is going to look at infrared light. And I think they made that decision because you can do a lot with an infrared telescope in terms of, say, analyzing chemistry of distant things. I know one of the exciting things I'm waiting for from the James Webb is they're going to attempt to analyze the composition of atmospheres of extrasolar planets, so planets around other stars.
They're discovering planets on a daily basis.
Oh, yeah.
Yeah,
we've discovered a few thousand at this point, confirmed a few thousand, 3,000, 3,500 known planets. There's like 4,500 candidates waiting to be confirmed. They think they are, but they have to confirm it to say, yes, it is.
And I think the infrared could see through the cloud dust, correct? That's one issue that some telescopes have?
Exactly. I mean, if it's an optically opaque cloud, an infrared telescope can see through it, depending on the nature of the cloud.
So what happens to Hubble after the James Webb Telescope is up?
Well, the Hubble orbits the Earth. It's at a slightly higher orbit than the International Space Station. I don't know if you know, the space station has to be boosted every once in a while to get it back up to its stable orbit, because it's slowly being slowed down by the Earth's atmosphere. There's a little bit of atmosphere up there, and as it moves through there, the drag slows it down, and it starts to descend. And that's naturally what would happen to anything, orbiting at 200 miles or so. Skylab, back in the 70s, they let it deorbit. They let it come crashing down and burning up. But yeah, the space station, they have to boost every once in a while. Hubble doesn't need that as much because it's higher up. It's like 300 miles or something like that. I don't know what their plans are for it. I know that NASA missions, satellite missions, have to have an end-of-life plan. They have to work into the mission how to destroy or bring down or park safely the dead satellite, or once it's no longer being used.
And we saw a perfect example of that with the Cassini probe.
Yes.
Which we'll get into later.
Right.
Yeah. Yeah, so let's talk about some of the satellites here on Earth. I know, reading a few articles in the last probably 8 to 10 months, everyone seems to be very excited because they have these giant telescopes and observatories around the Earth that have been built. And I believe they're going to go active this year, all of them together. And the idea is to focus on black holes and potentially give us a first image of a black hole.
Whatever that means, right? I mean,
exactly, yeah.
Well, yeah, there's obviously a lot of satellites, and some of them are telescopes. We've had telescopes in orbit around the Earth for a long time. And now we're starting to send telescope observatories out into orbits around the sun as well, just depending on what you're looking at. Yeah, black holes are obviously a favorite of people. They always come up to Chabot and ask about, tell me about a black hole. What do we know about them? Do you have any pictures to show us? So, well, not really any direct pictures yet. One new exception coming up is the gravity wave detections they've been making. So
I love reading about that, yeah.
So on the ground, we have, I think there's at least 2 or 3 different facilities that listen for gravity waves. Or I say listen because we tend to think of gravity waves as more of like a sound than light.
Yeah, it's the easiest way to conceptualize how it is.
It's a ripple of gravity, basically, going through the universe. And very bizarre events create them, including a black hole, in particular black holes that merge. So you have 2 black holes that merge together. It's a really violent event, for one thing, and it sends out a gravity ripple. So these ground-based gravity wave detectors have sensed black hole mergers, neutron star mergers, things like that. But gravity wave astronomy has the potential to see farther back in time toward the instant of the Big Bang than we can currently see with optical telescopes. There's a time when the universe was so young that there were no galaxies, there were no planets, there was just hot gas. And you can't see through that hot gas. It's like a cloud. But gravity waves, just like sound, can go right through it. So in terms of looking far out into space, the farther you look out into space, into the universe, the farther back in time you're seeing things as they were. So if we look, 5 billion light years out into space, we're seeing things as they were 5 billion years ago. And you can keep on going back by looking farther out. But
yeah, there's a great video that I saw on, of course, YouTube, but it starts here in our solar system. It zooms out and just keeps zooming out, and you see how small our solar system is compared to just one leg of the spiral of the Milky Way. Then you get to the Milky Way. Then you get to the distance between the Milky Way and the Andromeda galaxy. You keep zooming out. Then there's a cluster neighborhood of galaxies.
Right.
And then just a giant web of galaxies out there. And then eventually you get to what you're talking about.
Right.
That overall, would it be the infrared that you could see the beginning of the universe? Or,
yeah.
well,
actually,
at least what we can see.
Right now it's microwaves we're looking at, the what they call the flash of the Big Bang. Well, not really the Big Bang. It's the moment when the universe expanded and cooled to the point where that cloud of gas that it was made of was no longer opaque, and light could then fly out freely. It was released. The cloud basically evaporated, and light was happy to move anywhere. Because the universe has been expanding, what was originally very, very high energy light has now been stretched, if you want to think about it that way, into microwave wavelengths. So, they found this afterglow of the Big Bang in microwaves decades ago. They didn't know what it was that they were sensing with their microwave receivers, but that's what led to that and the expansion of the universe, the theory of the Big Bang.
Okay.
But the gravity waves, back to this, because you were talking about orbital telescopes, they are planning a space-based gravity wave detector, which will be 3 satellites separated by millions of miles, each one, but linked together with a laser beam. And it's the laser beam is going to keep very accurate measurements of the relative distances between these 3 satellites, with the idea that when a gravity wave passes through our solar system, the distance between the satellites will fluctuate very minutely.
But we'll be able to measure it
With those lasers, yes.
That's amazing.
And the distance we're talking about is far smaller than the nucleus of an atom. I mean, it's a tiny, tiny compression of different distance that's going to happen, but we'll be able to detect it.
And gravity is one of those things that is, correct me if I'm wrong, technically a theory. I mean, we know it exists because you can drop an apple and it hits the ground, and we can even measure it, but it's not something that we've been able to see, correct?
Well, I mean, so a long time ago, Newton's theory of gravity was that, gravity was a force, like a push or a shove or an electric magnetic attraction, that kind of a force. But when Einstein came along and he came up with the theory of relativity, his theory of space-time, of relativity, was that gravity is actually the effect of space itself, or space-time, being curved by mass, objects in it. So the idea is that an object, like a planet or a star or even your body, warps space-time around you, and that warping is what produces the effect of gravity. So it's tied to the theory of relativity. So it is still a theory. Obviously, we know that gravity is an effect. Like you said, you can drop something. You can feel yourself being pulled down. And when you go out into space, you can free fall in microgravity, as they call it. But
and like what you were talking about with the space station, you have to take into effect, because eventually gravity will pull it right back into.
Yeah. Well, the gravity and then the slowing of the space station by the atmosphere. If there was no atmosphere up there, the space station would keep on orbiting indefinitely. And for satellites that are farther out that aren't being affected by as much drag, one of the first satellites that was ever put up, the Vanguard satellite, I think it was put up in late 50s, early 60s, was one of the first satellites. It's still orbiting up there because it has a high enough orbit. It just perpetually loops around the Earth. It's those low Earth orbit objects that have to be boosted every once in a while, because the closer you get to the ground, the more atmosphere there is, and Earth's atmosphere, and the more drag there will be.
So let's talk about the Chabot Space and Science Center.
Sure.
You have telescopes there.
Yes, we do.
Now, the telescopes have interesting names: Nellie, Rachel, and Leah.
Yes.
How do they get the names, and what are the different telescopes used for?
Okay, so I don't know how long this story is going to be. I'll try to keep it brief. So Chabot Observatory began in 1883 when the first telescope, Leah, wasn't named Leah at the time, was bought for the city of Oakland. And from that point on, it was a public student observatory. So it was intended to be for the use of students and the public. So from the very beginning, it was not a research observatory. You know, they had a telescope, but it was mainly for people to look at the wonders of space through. So that was a Alvin Clark 8-inch refractor. So the main lens is 8 inches across. And that was located in downtown Oakland until 1915, when city lights had built up so much that they had to move the observatory farther from the center of Oakland. So they moved it to the second location in 1915 and acquired a 20-inch refractor, which became named Rachel. So at this point, the naming of those two happened. It's from a story in the Bible about how Jacob wanted to marry the younger of two sisters, who was Rachel. But the father of the girls said, "No, you have to marry my older daughter, Leah, and you'll have to work for me for 7 years before you can then marry Rachel as well." And so he did. And I think at the end of that 7 years, the father reneged on it anyway. But the director of Chabot had the older telescope for many years, but he wanted the money to buy a bigger, younger telescope. And finally he did when they moved to the new place. They bought the 20-inch, and so that's why he named them Leah and Rachel.
Okay.
So they're the two sisters, the older one, the younger one, the one the director had for years and then wanted a newer one. Nellie, on the other hand, Nellie was built in 2003, so it's a modern reflecting telescope. It has a 36-inch mirror, and that was named after the granddaughter of the donors who paid for it, Merrill and Lillian Martin. So I think it was also the grandmother's name as well. So they were Cornelia, so it became Nellie for short.
Okay. Now, what are these telescopes used for?
So our telescopes mostly are used for public observation. Every Friday and Saturday night, when it's clear, you can come up and look through any of these telescopes. So we have volunteers and staff who operate the telescopes, find beautiful things to look at, and you come up, put your eye to the eyepiece of any one of these, or all three, if you want to stand in line 3 times. It's well worth it. We also have a bunch of small telescopes that are brought out onto the deck as well. But so beyond that, we do have a core of people who, some are staff, some are volunteers, some are members of the East Bay Astronomical Society, who's been a kind of a partner organization with Chabot since 1923, I believe. And they use it for their own research purposes. So we have astrophotographers who take really amazing, beautiful pictures of the cosmos, a lot of which can be seen on our website. If you go down to the observatories page and pick out the telescopes, you'll find an archive of some really beautiful astrophotography. We have a team who track near-Earth objects, so asteroids mostly, comets when they come around, and track their motion and submit that data to the International Minor Planet Center, who track all of these rocks that have the potential of hitting the Earth. So they want as much information as they can about their orbits.
Now, sorry to cut you off here, but speaking of rocks around the Earth,
yes,
we all know we have a moon, but there's talk of a second moon that orbits the Earth. Is that correct?
That's correct.
It's just much smaller, though.
It's tiny. I don't have the number on my head, but it's I want to say it's on the order of a couple 100 feet across or smaller. I'd have to go check that though. But it's they've been observing it for some time now, and at first they weren't sure if it was a permanent, companion of the Earth. But it's in a kind of a bizarre little orbit that moves along with the Earth. So it accompanies the Earth, and it has a really strangely shaped looping orbit. But it's essentially it can be called a second moon of the Earth, at least for now. Might not be there forever. Our big moon's orbit is very stable, and it has been around for a long time, and probably will be for a long time more. But this is a small object. Its orbit could be affected by the gravity of another planet and eventually get kicked off and head somewhere else. But right now, it is following the Earth.
Yeah.
Yeah.
Now, the Space and Science Center, there's a lot more than just the telescopes and the observatory. You have actual exhibits there.
Yes.
So let's talk about some of the current exhibits and maybe some of your past favorite exhibits.
Sure. So right now we have 3 main exhibit halls. So we have Destination Universe, which we've had for a few years now, but it's kind of your astronomy 101. Talks about everything from stars to the universe in general. So it doesn't really talk about planets in our solar system, but from stars, nebulas, galaxies, star clusters, and then intergalactic space galaxies. It's sort of your primer for learning about that stuff. And all of our exhibits have fun interactive components as well. So you don't just go in and read things on the wall. You actually get in there and get your hands not dirty, but active.
But moving things.
Moving things.
Yeah.
Sometimes we bring out exhibits where it gets a little messy, but we have Beyond Blastoff, which is about living and working in space. So we have space artifacts, we have spacesuits, we have a Soyuz descent module, actual space capsule. You can go and see how people travel to and from the space station right now, which is through Russian Soyuz capsules. We have collections of space food. We have a space toilet, believe it or not. It sounds kind of weird, but people love it. Space toilet, really? How is that different from the toilet in my house? So you can
I remember I did a school field trip, and we went to like a science and space center, and they had a capsule simulator, and you can climb inside. Those spaces are so cramped, and some of these astronauts spend weeks or months up there.
Well, we have a little full-scale replica of a Mercury capsule. So the first American spacecraft was the Mercury. It took 1 astronaut. So it was the ones where they launched Alan Shepard and Gus Grissom and all them in the first. If you watched The Right Stuff, the movie The Right Stuff, that was the Mercury program. So you can come and climb into our Mercury capsule and see exactly what it was like for the first American astronauts. You can't climb into the Soyuz, unfortunately, because it's a real object, and it's got a lot of rusty edges and things inside you wouldn't want to deal with. But the Mercury capsule is safe anyway. We have an exhibit on the moon, pieces of the moon. We actually have a piece of the moon. We have an Apollo 15 moon rock. You can come and look at a real moon rock and otherwise learn about our moon. We have a kind of a combination exhibit / activity program going on now called Project Create, and we have a large exhibition hall that's filled with changing activities. We bring out different developed activities for kids to come up and really get their hands dirty in. Tech take apart, where you can take apart machines that were just black boxes to you before, or we have public art. You can come and make a stop motion animation. There's a whole range of things. You can engineer a marble run. So there's those kinds of activities going on.
Very
there.
cool.
Yeah, it is. It's been very positively received too.
And these are all current exhibits.
Yes, these are all things going on right now. And then, of course, our observatory deck is open in the day as sort of an exhibit as well. So you can come and learn about the telescopes and see them, and sometimes look through one of them. We have volunteers who will point Leah at the planet Venus during the day. People can come up and see Venus at daytime. They don't usually think they can see something in the day other than the sun or the moon. But if you have a telescope, you can. Some of the brighter objects.
And Venus is pretty bright at night, too.
Oh, yeah. Well, Venus is the 3rd brightest thing in the sky after the sun and the moon. So, yeah, it's quite a beacon. And when it's up and available at night, we'll look at that as well. Our observatory deck also is about to open a new expansion. We've been building an extension of the deck that will include a whole suite of outdoor interactive exhibits focused on observation. So each one has something to do with observing nature or making observations, not just looking through telescopes, that's part of it, but in general, how we observe the world around us in different ways. These exhibits were developed over at Exploratorium, so that will be opening soon. I'm not going to say when because they're still building it right now, but pretty soon. So we'll have a new outdoor exhibit going on as well.
Was there anything special done for the eclipse?
Yeah, other than the fact that we were clouded over, people came up and had a great time. Of course, there was a lot of build up to that eclipse, and a lot of our normal floor talent, our staff and volunteers who would do that kind of thing, weren't there because they went up to Oregon and Idaho and to see the totality, and then brought back really beautiful images and things. So we had, I don't know, at least 1,000 people come up to Chabot.
Wow.
And some people, everyone came armed with their little solar filter glasses that had become really rare, because everyone bought them up. We had a few, but our stock got sold really quickly, and the ones we were handing out disappeared. Unfortunately, no one needed them, right? Because most of the time it was cloudy. There were a couple times where the sun and, the eclipse came out for a few seconds, and people cheered, and they were happy. Beyond that, we were streaming NASA's coverage of totality from a whole string of places along the path of totality in our planetarium, our theater, and like 5 of our classrooms. So if you weren't outside looking at the real thing, which most of the time you couldn't, you could come in and see what it was like in Oregon.
Yeah, that's what I was
Idaho.
doing.
Yeah.
I was working in the office, but on one of my screens I had the NASA live stream going on.
Yeah, we had that on big domes and screens, and people found what they wanted that day, one way or the other. And the fact that the sun did come out for a few seconds kind of at least said, okay, you saw the real thing, right?
Yeah.
And you couldn't use your glasses at that point because it's already too dim from the cloud, but the cloud itself was being a filter. So people took off their special glasses and just looked at it, and they were happy.
Now, what's been your favorite exhibit all time?
At Chabot, my favorite exhibit was one we had like 12 years ago now. It was called Dragon Skies. So it was Astronomy of Imperial China. So it was an artifact-based and replica-based collection or exhibition on ancient Chinese astronomy, because the Chinese were doing sophisticated astronomy, thousands of years ago. And so what I loved about the exhibit, not only the story we told, and the environment we created in the exhibit, was the fact that it had so many real artifacts in it. So we had things that were thousands of years old on display. We normally don't have real artifacts at Chabot. We're not a collections-based museum, so we do a lot of interactives and replicas and models. So this one was special because I like old stuff. I like fossils. I like antiques, things that are real. I just like the fact that I can look at it and say, that moon rock is 3.3 billion years old. I'm looking at it. It's right there in front of me. That kind of thing.
That's just mind-blowing right there.
I have an amazing collection of fossils at home that my wife and daughter have bought me over the years because they know I love fossils. And so anyway.
Well, you know what? Yeah. Even if you think about it, I mean, it's amazing, to see a moon rock and know the age of it.
Yeah.
But if you just look at the land that we're standing on and how old this rock is, Earth.
Yeah.
Yeah.
Well, and when you get down to the geology level where you're looking at an individual rock, I was reading something recently about the oldest rock found on Earth. When we say that, of course, it's in its condition it was that many billions of years ago or whatever, as opposed to rock that changes from weathering over time. I think in Newfoundland, that's some of the oldest rock. It's like 3-4 billion year old rock there that hasn't been changed much at all in that time. And what's exciting about that now is they're actually analyzing the rock to see if there are signs of life activity on Earth, 3-4 billion years ago. And they're still debating and analyzing, but that's
and just to clarify for our listeners, life activity back then would have been microbes.
Microbes, exactly. Yeah, they know obviously microbes started at some point. The question is how early in Earth's existence did life spring up, and was it, immediately after the oceans formed, or did it take some time? And the evidence is kind of pointing toward life kind of sprang up as soon as the conditions were right, as soon as there was water in the oceans, and so that's pretty exciting. But yeah, the moon rock we have, like I said, it's 3.3 billion years old. That's comparable to the oldest rocks we can find on Earth, but it's actually one of the youngest rocks you could find on the moon, because that's about the time when the moon stopped changing. It doesn't have an atmosphere, and no longer does it have lava on the surface and eruptions. It's just been pretty much static, other than impacts by
So there was
asteroids.
lava at some point on the moon?
Yeah, I mean, early on, all the planets in the solar system were very hot. The heat that was generated when the material that formed them came together made their surfaces very hot. I think at one point Earth was probably completely molten on the surface, probably the moon as well. And then they cooled and they formed their crust.
Now, the moon, was that a big giant piece that broke off of the Earth at some point?
Probably the most favored.
Or was it ancient aliens that brought it over?
Yeah, exactly, right. We don't know, but no, actually the leading theory right now is called the giant impactor hypothesis. And the idea was that 4.5 billion years ago, when the Earth was very young and probably still largely molten, it was hit by another planet. So they're saying a planet maybe the size of Mars hit the Earth, merged with the Earth. So the heavy materials kind of merged down into the core. But the impact blasted a bunch of material from the crust and mantle out into space. So splash out into space, right?
Okay.
Maybe for a time Earth had a ring because of that, a ring of debris, that then ultimately condensed into the moon. So that's probably the leading hypothesis. They know
It's a little bit similar to Jupiter, right? And its moons? Something similar to that happened?
I think in Jupiter's case, its main moons, especially the 4 large ones, the Galilean moons, the idea is that the Jupiter and those moons formed out of the same disk of material that was spinning, and then they formed in place. Now, there's different theories about how exactly that happened. That theory is kind of similar to how we believe the whole solar system took shape, a big spinning disk of debris, of material. At the center, most of the material fell, and that formed the sun. And then out in this disk, the smaller bits stuck together and eventually snowballed into the planets. And, asteroids may be leftover material from that process, the comets as well. But with our moon, the idea was that we didn't have a moon that formed with the Earth until this collision. Partly what supports this theory is chemical analysis of the rocks they brought back from the moon shows Earth's signature in the moon rocks. So apparently a lot or some of the material that make up the moon originated on Earth. So that impact hypothesis is sort of the
That's
leading
pretty,
theory.
yeah.
As opposed to the moon was just sailing on by and got captured by the Earth's gravity. That was an earlier theory. So there are competing theories. And there's another one where the Earth, the moon and the Earth formed together at the same time from the same cloud.
And they just kind of rotated around each other. And
Right.
yeah. So let's talk about Europa.
Yes.
Okay.
It's exciting, yes.
Yeah. Now, you wrote a piece for KQED
Right.
on the upcoming mission. So there's a lot of talk here.
Mm-hmm.
And let's get into why this is such a big deal, because there are oceans there.
Right.
And I think the biggest thing that scientists are excited about is to discover, well, is there life there? And how did it develop there? And will it teach us more, which it should, about how life developed on Earth?
Right. So yeah, Europa is one of those really exciting places in our solar system for astrobiologists, people interested in studying, conditions for life in other places than the Earth. So early on, a couple decades ago, they theorized that Europa has an ocean hidden under its icy crust. So some of the original images showed, well, all the images we have of it, but early
I was
on,
reading it's like 70 miles deep, the ocean.
that's one, or more,
True,
But,
yeah.
yeah, they first kind of caught wind of this ocean that's hiding. We don't have any direct pictures of ocean waves crashing on shores or anything like that, because it's hidden under a complete crust of ice. So maybe under a mile or 10 of ice, there is this ocean that the icy crust is floating on. And it was originally cracks in the ice, the pattern of cracks in the surface crust of Europa that was consistent with this is a big floating raft of ice, or shell of ice floating on water. Now, it's not hard to extend. We know that a lot of the objects in the outer solar system, so Jupiter and beyond and their moons, have a lot of water ice in them. A lot of the moons have a lot of ice. We know that. The question is liquid water. We're interested in liquid water because for life on Earth, water in its liquid form is essential. Possibly for the origination of life on Earth, but certainly for its continued existence. So, the NASA follows the water. They look for the liquid water to find environments in our solar system that might be suitable for life. And Europa is a big one because, like you said, this ocean that's under the crust could be 50, 60, 70 miles or more deep. I saw one number as high as 100 miles deep. Now, what that would be like down at the bottom of a 100-mile deep ocean, is a lot of water pressure, Europa is a smaller object, so its gravity isn't as strong as the Earth, so you'd have to do some math on the water pressure there. But what they want to find evidence of is sources of heat down in that ocean. What's making it liquid, for one thing? What source of heat is melting the ice to keep it liquid? They're pretty much convinced that it's tidal flexing as the moon orbits Jupiter. The flexing of the...
and the power of Jupiter, like trying to rip it apart.
Yeah, it tugs it, it stretches it, and it contracts and stretches. And it's kind of like my analogy is if you have a lump of Play-Doh that's cold, it's pretty hard. But if you squeeze it and twist it and fold it, it becomes softer as you heat it up. So in a way, Jupiter's gravity is stretching and folding, producing frictional heat inside Europa, maybe down in the core. And then that heat may emerge through the ocean floor. On Earth, we have hydrothermal vents deep in the ocean, way down where it's really dark. There's no sunlight down there at all. It's really cold. The water pressure is really high. But there's these places where heat and heated water, chemical-laden water, chemical minerals from inside the Earth are coming out. And we have found thriving communities of life.
Planet Earth has a few specials on that.
Yes, and it's just fascinating. This is life that is completely independent of sunlight. It gets all of its ecosystem is entirely generated by heat energy and chemical energy coming from inside the Earth. So the fact that we have life on Earth, whether that life formed down there or is life from the surface that somehow managed to get down there and adapted, we don't know. But we know that the environment is suitable to sustain them. So Europa is exciting when you think about, well, if this heat generated inside Europa's core is coming out through hydrothermal vents of some kind, maybe carrying chemical energy, could that be a similar kind of environment to what we find on Earth's ocean floor in these spots? So could there be life in Europa's oceans fueled by this tidal energy heating the interior of the moon? That's really exciting. So one of the things they'll be looking for is any kind of chemical signs. We already know that there are plumes of water vapor coming out of the crust in some places on Europa. And one of the hopes is that we can send, the Europa Clipper probe through that and chemically sample the plume to see if there's any minerals in there that suggest, okay, where's it coming from? Do we see any chemical minerals coming out of that plume that may have originated on the floor of the ocean?
Now, is the expectation of that liquid water to be the same type of water that we have here on Earth, H2O, or is it a different type of liquid? Like I believe on Titan, it's liquid methane, right?
Right. So on Europa, it's almost certainly liquid water, just like H2O, like we have on Earth. We know that the crust of Europa is largely water ice, H2O ice. So, and the temperatures we're talking about here wouldn't be suitable anyway for liquid methane. The reason there's liquid methane on Titan is it's so cold there. Water on Titan is a rock. It's as strong as a rock. It does not melt. You don't have liquid water on the surface of Titan anyway. But methane, on the other hand, which is, it's a gas here on Earth. When you turn on your stove or whatever, you get gas coming out of there. On Titan, it's cold enough that is a liquid. So there's clouds and there's rain and there's a river runoff, they believe, and lakes and seas on the surface of liquid methane. But yeah, Europa would be a liquid water ocean, which is, really the exciting thing there. What's down there? Is there life down there? That's what we want to know. Yeah.
So they're sending a probe that will try to get inside of the actual, basically the vents through the ice, and take samples.
That would be nice. Well, sort of. At the very least, they would like to have the probe fly through the plume of water vapor, coming out.
Oh, just fly through it.
Yeah.
Okay.
So the Europa Clipper will make flybys of Europa, and some of them they're going to probably try to get pretty close to the surface. But no, the actual Europa Clipper is going to be orbiting Jupiter, I believe, and making a number of flybys of Europa, and as it passes, use its instruments to try and divine what's going on under the ice there. The chemistry, the physics. They can also do measurements of the gravity, how the moon's gravity affects the spacecraft as it flies by, to get kind of an idea of what's going on inside, what's liquid, what's not. They can also take magnetic readings to see if there's a big electrically conductive saltwater ocean down there that's perturbing Jupiter's magnetic field. So there's several ways they can actually kind of infer what's going on down there, make measurements indirectly. Obviously, sampling the water vapor coming out of the crust is sort of a direct measurement of the water that's down there, short of actually going down into the ocean, which is right now science fiction, maybe in the future. I know that part of the Europa Clipper mission is they want to consider a lander of some kind to land on a spot on the surface. It wouldn't go down underneath the ice. The technology to drill through miles of ice, get into an ocean that maybe is 100 miles deep and still be able to communicate with us, that's a little beyond what we can do right now. But that would be really cool. Yeah. I'd like pictures of jellyfish myself, but I don't know if that'll happen in my lifetime. We'll see.
Now, I know NASA has so many projects like this going on at one time, and we just saw the Cassini spacecraft last year just get crashed into Saturn. They returned some amazing images of Saturn. The thing that blows my mind away with Saturn, I mean, originally when I first learned about Saturn, the rings are beautiful, right? But now there's at the North Pole an actual hexagon shape of the clouds and gas. Like, it's just amazing. It's like perfect hexagon too.
Yeah. I'm sure somebody looked at that picture and said, I think aliens are doing that, right?
Yeah.
Do you find shapes like that in nature? Well, you do. You can find shapes like that in nature. But yeah, that was kind of a...
But you know what? Whenever I need a tool from my toolbox that's hexagon shape, I can never find it, right?
Yeah.
That Allen wrench.
Go to Saturn, find it there. No. Well, and similarly on Jupiter, the Juno probe, which has been flying around the poles of Jupiter, have shown us pictures of Jupiter's poles. No hexagons, but some equally amazing things that they didn't expect. Until then, we'd only seen Jupiter from the equator direction, right? So the poles are kind of at a really steep angle. But now that we have these wide open pictures of the poles of both Saturn and Jupiter, it's just really amazing what happens in the different places on those planets. And Saturn is just stunning. I think what came out of the Cassini mission that was the most gripping were the observations of some of the moons. In particular, Titan, one of the largest moons in the solar system, the one with the liquid methane, liquid cycle, rain and rivers and things like that, just stirs the imagination to think of a landscape that is so cold. If you took a dip in one of those lakes, you'd freeze solid in seconds,
Yeah.
But otherwise may resemble what we might see on Earth, or maybe a very young Earth. when water was flowing over the bare rocks of the Earth. And there's also some evidence that there may be liquid water deep under the crust of Titan, where its pressure is higher. But Enceladus, a much smaller moon, I think it's only 500 miles across, it's tiny, is like another hot spot for astrobiologists because they have detected the presence of liquid water there as well and inferred the existence of another ocean, under the crust of Enceladus. And similarly, actually, Cassini flew through the plumes of water vapor coming out and was actually able to sample some of the chemicals. And some of the measurements they made inferred the existence of some kind of a hydrothermal vent, environment down on the floor of Enceladus's ocean. So that's another place that we would want to go and look for signs of life of some kind. And that was actually one of the reasons, the main reason that Cassini was incinerated in Saturn's atmosphere, was to prevent it from colliding with one of these moons, Enceladus in particular, that might have life on it. So we didn't want any, hitchhiking Earth microbes that might be on Cassini in a hibernating state to contact a potential biosphere on one of these moons. So they self-destructed Cassini in a blaze of glory. I mean,
Yeah.
they followed it until it sent back some really amazing pictures in its last seconds or minutes. They did the same thing with the Galileo probe around Jupiter, years ago, for the same reason.
Yeah, and that's what you were saying earlier, that every single one of these has basically an exit strategy or an ending strategy,
Right.
and how they're going to get rid of it.
Yeah, the sort of the greening of space missions, right?
Yeah.
Or it's.
What's the plan for the Europa mission for the Clipper?
I haven't seen specifically. I'm sure they have a similar. Well, and that also brings up the question. Okay, so if they're going to self-destruct this orbital probe at the end of its life, so it doesn't, contaminate Europa or some other moon, if they're going to put a lander down on the surface, how are they going to prevent it from contaminating whatever is down there? So that's something to look at. I mean, obviously we've landed a lot of things on Mars, and they do go to great lengths to try and sterilize all the robots we land on another planet. So I assume that similar things would be done to anything they might drop down on Europa, in terms of trying to. You can't be 100% sure that there's not one little microbe hiding
Yeah.
in there somewhere, but they take extra care with things that they're actually going to contact the surface of a planet or a moon.
Yeah. Now, you just mentioned Mars, and Mars is on everyone's radar right now, it seems like.
Has been for 150 years.
Yeah. You have Elon Musk and SpaceX. They want to get to Mars, I think, by 2025 or 2030, something very ambitious. Then you have NASA talking about 2033.
Yeah.
Then you have, I believe the European Space Agency or some other. No, actually, you know what? It was Lockheed that came out and said that they're also going to compete and get to Mars by 2035.
It's a new
So what's
space
your
race, right?
Yeah, exactly. And so it's very exciting because we're talking about within the next, it's not even 2 decades. I mean, so what's your opinion on it? Are we realistically going to get to Mars here in the next 10 to 15 years?
Very good questions. Anything like this, it's a very expensive thing to do. It takes a lot of preparation. Anyone who goes, of course, is going to have to be away from the Earth for years. So there's a lot of considerations.
Well, it's apparently a 6 to 8 month trip to Mars, right?
Yeah, and then you got like 2 years before you could come home because we only send spacecraft right now between Earth and Mars when the planets are closest. So when Earth passes Mars in its orbit, we have a closer orbit to the sun, so we go around faster.
So that's every 2 years?
About every 2 years, approximately. So you're going to have to be on Mars for some time before you can actually get that launch window to come home again. That's with the technology we have right now, that's how they would handle it.
So sending people to Mars is more than just sending people for 6 to 8 months,
Yes.
and then, they're going to have enough supplies for both trips plus 2 years,
Right.
at minimum.
And one strategy they've talked about is sending supplies there and return rockets, vehicles, ahead of time, without people on them, and then putting the people on a express tour, basically an express rocket, to get them there as quickly as possible, 6 months or so. and then everything they would need would already be there. They kind of, in the movie The Martian, if you saw that, they had done that. They had put the return vehicles down on the ground at the future landing sites. That's how our favorite hero there gets back to space.
That was Matt Damon, right?
That's right. He traveled over to the next planned landing site where the return rocket was waiting for him. So that's an idea that they've talked about, because sending things anywhere costs a lot of money, and the more things you send, the more it is. And if you can send supplies there on sort of a slow boat, it can be done more cheaply, and then save the speedy trip for the astronauts who might get bored, otherwise spending too much time in space. But as far as going to Mars, I think it would be an enormous human adventure. I mean, the moon.
I mean, that's a huge step. I mean, the moon was a huge step in itself.
Yes.
But now you're talking about interplanetary.
Right. And I think we've been practicing for doing this kind of thing for a long time. I mean, on the International Space Station, they have been conducting experiments with the psychology and the physical health of astronauts, and trying to see how long you could stay up in microgravity out in space weightless, how you could grow your own food on the way. They're growing lettuce up on the space station right now just to see what the possibilities are for that. So they're trying to find how we would do it and if we would survive and remain healthy. And people have stayed on the space station for over a year in some cases, and by continuing to exercise rigorously and watching your diet and all this, they've managed to stay pretty healthy. So I think we're learning how to make the trip there. And we have landed spacecraft on Mars, so we know how to land. I mean, most of the rovers have gone down bouncing in a big airbag kind of a thing, but the Curiosity rover actually was set down very gently by a rocket-propelled crane. So we know how to put things down on the surface safely. So the steps of the way can be done, I think. Radiation from the sun is a big problem, shielding the astronauts. Once they're outside of Earth's magnetic field and atmosphere, they're exposed to potential space storms, eruptions from the sun that send out dangerous radiation. So those kinds of things will have to be dealt with.
And then Mars' atmosphere is not 100% stripped, correct? But it's very, very...
It's about 1/100th the thickness of Earth's atmosphere, and it's mostly carbon dioxide. There's a little bit of water vapor and some other things in there as well. But so it's carbon dioxide, which is toxic to us. We can't breathe that. And it's really thin. So it's almost like going up to the moon where there's no atmospheric pressure. Well, there's some atmospheric pressure on Mars, but you wouldn't survive, walking around on Mars, certainly. Even at its warmest, I think the temperatures at some places can get up to above freezing, but for the most part, it's very cold there, too. Big, cold desert.
Yeah.
But yeah, I think going to Mars would be exciting for a number of reasons. One is just the human adventure aspect, which, I'm kind of on the fence about whether that's worth the great amounts of money that it takes to do. Because I see what we can get out of robotic missions, which we can do for a fraction of the cost, and see how much we've gotten from things like Cassini and New Horizons and Galileo and all the robots we send out into space. We can learn scientifically a lot. But, there's arguments about how a scientist down on the ground on Mars can make decisions on the spot and potentially, walk over there and dig up this fossil, based on judgments on the ground kind of a thing. So potentially there's more exploration that can be done if you put people down. But then there's this whole argument of, well, should we colonize Mars? Should we put people there permanently in a self-sustaining, community of some kind, whether that's, a spacecraft or, a pressurized dome on the surface of Mars, because it's not livable right now. But some people argue that as long as the entire human race is just on the one planet Earth, we're vulnerable to an extinction level event. If the human race gets wiped out on Earth, we don't exist anywhere else except in alien laboratories on spaceships out there, right? But if we have people living on Mars and they are a self-sustaining group, they don't depend on the Earth for anything, then that increases our species' chances of survival. Personally, I think we should do what we can to protect our home, because there's no planet that we know of right now that's like the Earth, that can provide for us the way it does. But that's another argument. It's just increasing the chances of our long-term survival.
Yeah, and Kepler's been discovering a lot of planets lately.
Oh, yes.
I mean, thousands per year now. It's
Well, I
like
think-
the going rate.
Yeah, I think we're up to a total from all spacecraft. Most of these actually by the Kepler mission, but I think the 3,500 confirmed extrasolar planets or exoplanets, around something like 2,300 different stars.
Now, are these all around the habitable zone?
Not all of them, but they are finding planets within the habitable zone, that range of distance where liquid water could be found on the surfaces. So the Earth obviously is within our sun's habitable zone. And what they're really looking for, and that's what Kepler really was designed for, was to look for Earth-like planets. That is, Earth-sized planets within their star's habitable zones. So the idea was to find a potential other Earth. And they have a few candidates right now, which are pretty close to Earth size, well within the habitable zones of their stars. And so they would be really good candidates for follow-up observations, like with the James Webb Telescope, to see if they can detect any chemical telltales of life. From a distance, you might look back at the Earth and analyze the chemistry. And one of the points some people make is, well, if you find a lot of free oxygen in the atmosphere, then something must be producing that oxygen, kind of like plants, right? Because oxygen left to its own devices will turn into other compounds, will chemically react. So generally speaking, it's not stable unless there's something producing it. Methane is similar as well. So we're looking for methane coming out of Mars, maybe, to see if there's any microbes under the surface making methane. So those are the kinds of chemical telltales we look for. And we can do that with these exoplanets. There was last year, I think, the TRAPPIST-1 star system.
Oh, yeah.
It's a red dwarf star. It's pretty small and dim.
And it has like 6 or 7.
It has 7 planets. Yeah, it has 7 planets, 3 of which are in its habitable zone. And they're about Earth size. So very exciting. Only 40 light years away, too, right? It
Yeah,
only take you 40 years to get there at the speed of light.
Yeah.
Just take the Millennium Falcon up there. And 40 years later? No, right? So,
Now, let's switch this up a bit. Let's talk about alien life.
okay.
Okay. I want to get your opinion on alien life. Is there alien life out there?
Mm-hmm.
What type of alien life? Are we talking about microbes? Do you think there is advanced civilizations out there? What's your opinion on it?
I think that it's really likely that there's life out there, just from the vast number of planets we're finding, and we can extrapolate the number of planets that probably exist in our galaxy, and we can even narrow it down to, there may be at least 3 billion planets like Earth in our galaxy alone, with water on its surface, with, close enough to the sun so that, life could live with solar energy. So I think we're looking for microbial life in our solar system. We want to look in the ocean of Europa. We want to look under the crust of Enceladus. We want to look in Mars, if only for fossils of life that once existed there. So I think that would be the most likely kind of life you would find, because I hope it's common. I hope it's out there everywhere and we can just find it once we start looking for it, which we have. As far as intelligent life or technological life, we're looking for that too. So places like SETI, Search for Extraterrestrial Intelligence, are listening for transmissions from other civilizations. Haven't heard any yet. So at this point we have not detected life out there, of course.
Now, I've heard one argument for that is we could be using, especially if they're an advanced civilization, they're not going to be using the same technology we are.
Right.
And so we might be listening for the completely wrong thing.
Sure. There's a lot of factors here that could explain why we're not hearing anything. Not just the distances, the huge distances involved. in some cases. But yeah, what are we listening for? We hope to. We're listening to radio transmissions. There's an optical SETI program that looks for visible light, telltales, and lasers, and things like that. And we would hope that we would recognize something of intelligent origin when we hear it. At first there were natural sources of radio signals, like from pulsars, rapidly rotating neutron stars that send out these pulses of radio waves, which we hear as these high frequency, sounds kind of machine-like. It sounds like a washing machine out of balance and spinning around, and it says, hey, is this a machine out there producing it? But there are natural sources of things that can sound that way. So we have to sort of listen beyond that, look for something more, quote, intelligent, in the signals. So I know that SETI, they listen for transmissions on a lot of different wavelengths. So they're trying to listen to as much as they can. But then there's the other question, are these more advanced alien civilizations that may be out there not transmitting to us because they don't want us to know that we're there or something like that?
Yeah, definitely a lot of theories and ideas on why we haven't made contact with intelligent life.
Right.
And of course, there is the one possibility that we might be the first.
Yeah, that's certainly possible.
Yeah.
I mean, that we know of other star systems that have been around much longer than ours, that, similar stars to our sun, which you could, theorize, well, it has had much longer time for alien civilization to crop up and be intelligent, if it survives its infanthood. So why wouldn't we be hearing something from them if they've been around for a long time? So that's all part of the paradox of why don't we hear anything even though we're listening for it. I mean, on one level, the signals that might come out, the signals we're sending out into space, our radio and television transmissions that we aren't even directing into space deliberately, would be pretty weak by the time they got most places. Not undetectable, but pretty faint. So, could just be the nature of our equipment. How sensitive is our equipment? How sensitive does it need to be? If it's a civilization that's deliberately trying to be heard, you'd assume that they'd send out a very powerful beacon or transmission, right? And there have been people who have said, should we be transmitting into space and alerting other civilizations to our presence?
True, that's another
what if they're
discussion.
hostile? So, it's really an open-ended question. The fact is, we haven't yet detected a microbe on another planet or moon. We haven't yet heard an artificial transmission of some kind. But we're listening and we're looking. So, I mean, I like to think that we're going to find some kind of evidence of life out there within my lifetime.
I think if you just look at the statistic of the chances of life developing on Earth,
Mm-hmm.
and then you look at the number of stars just in our neighborhood, and then our galaxy, and then all the different galaxies out there,
Right.
there's got to be something you would think.
You would think.
Yeah. But then it comes down to, well, are you ever going to find out? Are you ever going to know?
Right.
And that just becomes a distance communication problem. And like you said, Millennium Falcon, got to have it, right?
Yeah, we need to go faster than light to get it. I mean, I don't know if that's possible, but actually there are physicists who are working on, possibilities for faster than light travel, even a warp drive. There is a concept for a warp drive.
And that's very interesting, too, because I guess the concept would be you're basically just pulling the space-time
Yeah,
to
something
you.
like that. It's
And then
science
it's like
fiction,
stretching out the space-time behind you. Yeah.
Right.
Yeah.
I think the one I'm talking about is called the Alcubierre drive. So
Okay.
A physicist named Alcubierre had come up with this idea. But just like you said, stretching and compressing space, kind of like, Star Trek had it with their warp drive.
Yeah.
We're warping space so that even though we're not moving faster than light within our little bubble of warp, the bubble can move along, right? Kind of like a surfer. A surfer on a board can't move very fast by themselves, but if they get on a fast-moving wave, they can go really fast. So,
Yeah. Okay, Star Trek or Star Wars?
what's the question?
What's your favorite?
Okay, I would have to say Star Trek. From very early on, I remember back in the 60s when I had an 8 o'clock bedtime, going in and peeking around the corner at my parents watching Star Trek on our little black and white television. So from a very young age, I really wanted to see Star Trek. And I love them both, but they're different stories for me as well. I just got into Star Trek, I guess. I'm on that vein. But it doesn't mean I don't love Star Wars, too. But I would,
So I do want to talk a little bit about Star Wars.
Sure.
So this evening, the San Francisco Giants, some of the employees were invited to the Lucasfilm campus in San Francisco to do a special screening of Star Wars, The Last Jedi. My buddy works for Giants. I'm actually going there tonight.
Oh, awesome.
And so I do want to ask a few Star Wars questions.
Okay.
Now we were briefly just talking about it
Yeah.
before the show. And you broke it down, I think, perfectly. It's a Renaissance story if you took out all the space stuff out of it.
Yeah, it's a swords and sorcery kind of fantasy story. It's a kind of medieval or Renaissance, like you said, if you take all the technology and the fact that it's in another galaxy and they're traveling between stars. In some cases they use science concepts like hyperspace. There is a science concept of hyperspace, but it's really only a tool or vehicle for the story.
And this is where Star Trek really excelled in that they focus more on the science, correct?
Yeah, they took, I think, more like classical science fiction, central themes that were based around some concept of science or nature and built a story around that. And they used their technological tools as well, like the transporter was just a vehicle at the beginning to move people around because they didn't want to do the fancy special effects of a spaceship landing on a planet. So, hey, let's just have them dissolve and appear on the planet below. That's low cost. That's cheap for the producers, But later on, there were episodes that actually got into the how would this work, really? They didn't really answer it because it's a complicated process. But there are physicists now that have, quote, created a transporter. That is, they've been able to duplicate information in 2 different places using lasers and mirrors and all of this. So
Yeah, they've been able to teleport little information packets.
Right, exactly.
Yeah.
So that's kind of like the first step of a transporter.
Yeah.
So
I think they have one of those devices in Europe. I can't remember where, but they were able to teleport an information packet from, I want to say 1 or 2 miles.
Yeah, I think they've gone beyond that now.
Okay.
I think the last I heard, there was a 14-mile. I don't know if it was a team in Japan or China, but they had broken the record at some point. But
I imagine they're just going to keep breaking the record
oh
at
yeah,
that point.
sure.
Now, an information packet too. I mean, what is that?
Well, what they were doing was they were, to break it down, duplicating the physical state of a photon in 2 different locations. Now, I'm not going to go into the details of it quantum mechanically, but well, that was the idea behind the transporter. Is
Yeah.
if you,
So
yeah.
we're still long, far away from actually transporting a human being.
If ever,
Well, then the question with
Yeah.
that is, are you just being duplicated or is it really
Right.
you?
Exactly.
Yeah.
There was actually a Star Trek fan novel a long time ago that kind of touched on that. Dr. McCoy was kind of lamenting that he's not the original Dr. McCoy. It's the first time I was transported, I was made into a duplicate McCoy, and the other one was destroyed. And that science fiction topic has touched upon a number of stories I've read. But are you the original?
Yeah.
Are you just a fax?
So I know one big thing with Star Wars is the Millennium Falcon doing the Kessel Run in less than 12 parsecs. So I can already hear it in the
That's
tone.
one of my nitpicks.
Yeah.
But yeah,
Now, what's the biggest misconception here?
well, they're using the word parsec, which is a real scientific term, in terms of a unit of distance, or no, time, right? So he's saying in 12 parsecs. I think in The Last Jedi, it was the previous one, the Force Awakens. The character Rey said, "Is this the Millennium Falcon that made the run in less than 14 parsecs?" He said 12. So that's already time, right? But it's actually a unit of distance in astronomy. So a parsec is the distance you would have to be to see the distance between the sun and the earth, one astronomical unit, as one as an angle of 1 arc second, which is 1 degree is 60 minutes, and 1 minute is 60 arc seconds. Anyway, it's a tiny, tiny angle, but it's about 3.2526 light years. So 1 parsec is about a little more than 3 light years. So
Okay.
it's a unit of distance, and that is used improperly in there. That's been done before. I remember in the original Battlestar Galactica series, they were using the word micron as a unit of distance. But a micron is a millionth of a meter. It's a thousandth of a millimeter. It's tiny. But they were using it as if, miles, So they just used the wrong word, but that's happened before.
The story writers.
Right. Come on, make up a word. Don't use it.
Yeah.
Or if you're going to use a real word, use it properly.
Okay, so if someone's interested in going to Chabot Space Science Center, so they can go to the website. What's the website?
www.chabotspace.org. So CHABOTSPACE.
And where are you guys located?
We are on Skyline Boulevard in Oakland, at the edge of Joaquin Miller Park. So if you go up Joaquin Miller Road or Skyline, you can find your way to the last bit of Skyline Boulevard before our driveway. We're right on the ridge. We're about as high as you can get. In fact, our elevator shaft top is the highest point in Oakland right now, other than the redwood trees surrounding us. Okay. But a little higher than Redwood Peak, which is just not far away from us. So, and there's plenty of parking. Unless you come during a solar eclipse when 2,000 people have showed up at Chabot. That doesn't happen that often. If you're coming for the telescope viewing, just come up and park in the garage or drive over to our back parking lot, and you walk in through the back gate, and it's free.
Perfect.
Yeah, but if you want to come into the center, we're open Wednesday through Sunday, 10 to 5, to come in and see our exhibits, see our shows in the planetarium, and have a good time.
Great. So we'll go ahead and link up everything in the description for anyone that's interested. So I want to thank you for being on the podcast here. We discussed a lot. I think there's like a million more things we can discuss. But thank you.
You're welcome. Thank you for having me.
It's been a lot of fun.
Thanks for the beer.
Yeah. Thank you so much for listening to the podcast. Thank you to our producer, Sam Levin. Please subscribe, like, comment, and share the podcast. Remember, you can listen to the podcast on iTunes, Podbean, iHeartRadio, Google Play, SoundCloud, and anywhere else you listen to podcasts. For more information on my business as a property manager and real estate team, go visit my website at markguzman.com. I really want to thank all of you for listening. It means the world to me, and I hope today's episode provides you value in your day-to-day life. I created this podcast to help showcase the many great people that live in this world and help share some knowledge that I've learned along the way in life. Again, thank you for listening. Check out our sponsors, and I'll catch you on the next episode.